In this video, we will talk about applications of the cross product to torque in physics. Alright, so let's begin by saying what torque is. So the torque, and the way I notate torque is, we write the Greek letter tau, and torque is a vector. Okay, so torque with a symbol is the Greek letter tau. So the torque is the angular force. So what I mean by angular is, it's a force that twists. It's a twisting force. So it's the angular or the twisting force on an object. Alright, so I'm going to draw an image. So let's say that we have a bolt. Okay, so here is a bolt. And then I'm going to draw a wrench. So a wrench. Oops. So I'm going to do my best to draw it. Okay, so the other side of the wrench. That one doesn't look that nice. Let me do that one more time. Okay, there we go. And then draw this part, then have it come down, and then come back. Okay, cool. That looks a bit better. And then we'll draw the handle of the wrench. Okay. All right, so we have this wrench that is twisting this bolt here. Okay. So in terms of vectors, what's going on is, if I look at the center point of the bolt, and then I put a vector starting there that ends at the part of the wrench that we are applying pressure to. So whatever our hand is holding. So let's say that vector sort of extends here, and that's the point that we are sort of pushing on. So I'm going to call this vector R. And then there's a force that we are applying to this wrench. So maybe that the force is coming in at an angle. Maybe it's like this. But of course, as we'll see later in this video, that's not the optimal direction to apply the force, but maybe it is the direction that we are applying it in. And again, so this object here, this was the wrench. So this was the wrench. Okay, so the angle in between these two vectors is going to be important. So this theta, this angle here. So it turns out that the torque vector is equal to R, that R vector, crossed with this force vector. So it's a cross product. Okay, so that is a cross product. Okay, so I'm going to highlight that as well, because this is a pretty important equation in physics. The torque equals R crossed with this force. So you might be thinking, wait, when we talk about the angle between two vectors, usually the vectors sort of have their tails in the same spot. But here, these vectors have their heads in the same spot. So the reason why that actually doesn't matter is, if we take this force vector and we move it, because remember, when we move a vector, as long as we keep the length, as long as we keep the direction, it's the same vector. So if we were to move that vector and put it here, so let's make it have the same length and same direction. So if I were to just sort of think about the force vector being moved there, this is actually the same angle. This is theta as well. So theta is the angle between these two vectors if we were to line them up in the conventional way. Okay, so there are a couple things that we want to happen now. Okay, so I'm going to write down what we want. And there are two things. So the first is the torque. So the torque is going to be pointing in a direction that's perpendicular to R and to F. So perpendicular to R and F, and it'll satisfy the right-hand rule. So the torque, we want it to point in the direction along the bolt. Because that'll maximize, that'll sort of like that'll make it easier for the bolt to move. Okay, so I'm going to draw a picture of the bolt from a side view. So, okay, let me make it a little bit better. So bolt from a side view. Okay, then that'll be, trying to make it look a little bit more 3D now. And then we have the rest of the bolt, and I'll draw some lines to make it look like it's curving around, and these are sort of the lines that we typically see on the bolt. Okay, so that's one thing that we want to happen. We want the torque to sort of be pointing in the direction along the bolt. All right, and there's one other thing. We also want the torque to be as large as possible. Because the bigger the torque is, the bigger that torque force is, the more likely it is that we are actually going to be able to make this bolt move. And move more easily. So 1 and 2 collectively are better to move the bolt. And that's typically what we want. We want to be able to screw in or remove the bolt. Okay, so how do we make this happen? So we want the torque to be as large as possible. So let's look at its length. So the length of the torque vector would be the length of r cross f. But we know how to take the length of a cross product. That's the length of the first vector times the length of the second vector times the sine of the angle that's in between them times sine of theta. So how do we maximize this? We can maximize the length of the torque vector when sine theta, so assuming that r doesn't change, assuming that we haven't changed the length of our wrench or anything like that, and assume we have a sort of a fixed force that we can apply to it because we have a limited amount of strength, what we do have flexibility with is sine of theta. So we can maximize this when sine of theta equals 1, because that's the biggest sine of theta will be. And that happens when theta equals pi over 2. So what that means is, if we want to sort of optimize our ability to move this bolt, we want this force to make a 90-degree angle with that r vector. So with sort of the handle of this wrench. So in terms of our picture one more time, if we were to apply a force in this direction, so if our force is in this direction, that's not really ideal. That's a bad direction to be applying force in. Similarly, if we were to come in at an angle on this side and apply a force this way, that's also not ideal. The best direction to apply that force would be at a 90-degree angle. So at a 90-degree angle, this would be the best direction to apply the force because it's going to maximize sine of theta and make sine of theta be equal to 1. All right, so I want to write out an observation now, which is if r and f are perpendicular, so if we got them in a perpendicular orientation, but the bolt still doesn't move, then we either need to increase the length of r or increase the length of f. And the easier one to do is increase the length of r typically, unless we were holding back in terms of how much force we were applying. So to increase r, we get a larger wrench. Okay, so to illustrate why this is useful is, so the length of the torque vector is equal to the length of r times the length of f times sine of theta. So if we double the length of r, so doubling the length of r will double the torque. This will double the torque. And that's just as good just as good as doubling the force. Or in other words, being twice as strong. Just as good as being twice as strong. So we have finished our last learning goal from this section, talking about torque in physics and applying the cross product to it.